Hello everyone, welcome to Computer Science 401, lecture number 6. Okay, today we keep talking about theoretical foundations of compilers of computer science. Okay, so last time we discussed the whole procedure, like we had an overview of how the code is being compiled. Okay, so today we'll be talking about we'll kind of dive deeper into each one of those processes. Okay, today we'll be talking about tokens. Okay, so tokens are the basic building blocks of programs. Okay, so the shortest strings of characters with individual meaning. Tokens come in many kinds, including keywords, identifiers, symbols, okay, and constants of various types. Okay. Some languages have only a few kinds of tokens and of a fairly simple form. Other languages like C are more complex. Okay. For example, it has almost 100 kinds of tokens. Almost 100 kinds of tokens, including 37 keywords. Okay. For example, double. Okay, so that is a keyword. That's a token. Okay. If, return. Okay, struct. That is something which we don't really have in Java, but C has it. It's basically like, in C you can't really have a class. Okay, so kind of the way you substitute it with the way you create an object in C, you would create a structure. Okay, so struct is the keyword for that. So like basically everything which is highlighted in Eclipse, okay, that would be keyword. Okay, so there are like 37 of them in C. Okay, then identifiers. Okay, for example, age, my variable. Okay, your type. Okay, so basically any kind of the variable name, there will be one of them. Okay, also size off. Okay, print f. Next, numbers. Okay, so basically, for example, integers. Okay, how can I spell an integer, right? I can say 0765. I can say 0x, okay, which means it's hexadecimal 1f5. Okay, I can say just, I don't know, 501. Okay, I can do that. Okay, floating point. Okay, something like 60022 e. Okay, so to the times 10 to the power of 23, for example. Okay, so that would be like a token, right? Character. Okay, for example, if I have x, okay, or if I provide the code for the character, okay, so there will be one token. Okay, 54 punctuators. Okay, so what do we have? Plus, minus. There is something like which is like so this thing that represents a dot. Like in Java you have an object dot and then the method name, or object dot and the field name. So in C you would do it with a struct. Okay, and the way you go between an object and let's say the field name would be this kind of arrow. Okay, multiplication and equal sign. Okay, colon or semicolon. Okay, boolean or, for example. Okay, and two different forms of comments. Okay, So that will be all tokens. There will be tokens. Okay. So to catch those tokens, to recognize them, right? To specify tokens, we use notation of a regular expression. Okay. A regular expression is one of the following. Okay, now we get into a formal definition of regular expression. Okay, so it can be a character. It can be an empty string. Okay, so denoted as, maybe let's actually draw that. Insert special character, jik. Okay, so this one. Okay, I'm gonna write E from now on. Okay. Well, no. I'll be just actually writing an epsilon. Okay. So there is that. Next, two regular expressions next to each other. Okay. Meaning any string generated by the first one followed by, okay, so in other words, concatenated. Any string generated by the second one. Okay, got that. Next, two regular expressions separated by a vertical bar. Okay, like this. Meaning that any string generated by the first one, or any string generated by the second one. Number 5, a regular expression followed by a clean star, meaning concatenation of 0 or more strings generated by the expression in front of the star. Okay. Cool. Okay. So let's create a set of regular expressions for the calculator. Okay. Okay. What is that going to look like? Okay. Sorry. It's going to look like kind of like grammar, but it's not grammar. Okay. It's going to look like a grammar, but it's not grammar. It's actually a set of regular expressions. Okay. So a number is going to be anything like integer or real. Okay. An integer is going to be concatenation of a digit and digit star. Okay. Real is going to be an integer, exponent, okay, or decimal and then exponent, okay, and empty string. Moving on, decimal. What is that going to look like? It's going to be digit, star, okay, and then either dot digit or digit dot, and then digit star. Okay. Next, exponent is going to look like the following. Okay, so we either going to need to have e. Okay, and this e is different from epsilon. It's actually e. That means again 10 to some power. Either this e or capital E. Okay, because technically they're both allowed. Okay, and then after that we're going to have either plus or minus or nothing. Right? So like if I don't have a plus, I would have nothing. And then integer. Okay. So that's how we create exponent, right? So again, it's e okay, and then plus or minus or nothing, and then an integer. Okay, and then we have digit, the simplest one, right? So it's either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. That's it, right? So 10 is already 2 digits. Okay, so basically, again, for the calculator, no matter what kind of, like in your calculator, right? No matter what kind of number you're trying to type in, it has to be, well, yeah, so nothing's going to work unless it will be matched against these regular expressions. Okay, so that will be, again, look, it looks like a grammar, but technically it's a regular, it's a set of regular expressions. Okay. So the symbols on the left of the arrow provide names for the regular expressions. Okay. One of these will serve as a token name. Okay. For example, number. Okay, number. The others are simply, for convenience, in building regular expressions. Okay. Note that while we have allowed definitions to build on one another, nothing is ever defined in terms of itself. So you do not have loops, okay? You don't have loops. Like in grammar, you would have loops. Like here, you don't really have it. So you can't really define integer through an integer, or real through real, exponent through exponent. In grammar, you can do it. Okay. Moving on. Okay. Let's talk about grammars. Okay. CFG, context-free grammars. Okay. Regular expressions work well for defining tokens. They enable, however, to specify nested constructs. which are central to programming languages. Okay, so consider the following example of context-free grammar. Okay, so we have expression. Okay, which derives to ID or number or minus expression or expression in the parentheses or expression. So here we're going to do up. Okay, so which is an operator, an expression. Okay, let me make this one italic. Okay, okay, so here I'm going to have that italic thing. Okay, so an operator can be, it derives either plus or minus or star or division. Okay, cool. So that is an example of a grammar. It's not a regular expression. Okay. Here, the ability to define a construct in terms of itself is crucial. Okay, among other things, it allows us to ensure that left and right parentheses are matched. Okay, which is something that cannot be accomplished with a regular expression. Okay, so regular expression cannot count parentheses. It can't make sure that they match. Okay. Yeah. Next. Each of the rules in a context-free grammar is known as a production. The symbol on the left-hand side of the production is known as variables. Okay, variables or non-terminals. Okay, there may be any number of productions with the same left hand side. Okay, symbols that are to make up the strings derived from the grammar are known as terminals. Okay, and they cannot appear on the left hand side of any production. Okay, cool. One of the non-terminals, usually the one on the left hand side of the first production, is called the start symbol. Okay, it names the construct defined by the overall grammar. Okay, so for example, in this case, it's going to be expression, it's going to be start symbol, and that basically defines the whole thing we're trying to create. We're trying to create an expression. Okay, cool. That's it for today. Hope you guys enjoyed this class. I'll see you next week, hopefully in person. Have a good one. Bye-bye.